How's it going, everyone? Welcome to the next video on exponential functions. Today we're just going to have a look at some graphs, or what an exponential function looks like as a graph. We've had a look at some of these earlier, so this will hopefully be pretty quick, just a bit of a refresher over how we go about that. So to start off with, exponential functions are functions in the form as followed. F for values r to r, f of x equals a to the x, where a is an element of all real positive numbers excluding 1. Okay, so they provide mathematical models, especially for exponential growth and exponential decay, situations such as population increase and radioactive decay, as a couple of examples. So, to start things off, let's have a look at the equation y equals 2 to the x. Just as a quick refresher, if you don't know how to do a graph, if you see something unfamiliar, very basic step to go by is to use the table of values. So go y, x and y. Table of values, pick a few numbers, so generally around the 0. Okay, there's some numbers, and then in the other bottom line, we'll fill out the corresponding y values. So at 0, 2 to the 0 is 1. At minus 1, we get 2 to the power of minus 1, so it's the 1 over 2. 2 to the minus 2 is going to be 1 over 2 squared, which is 1 over 4. And then similar for 3, we're going to get 2 to the power of 3, which is 8. And then over here, we get 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So there's our numbers. So table values, always a good starting point for anything unfamiliar. Next thing, we're going to have a look at graphing those numbers. So what does it look like? So got a set of axes. Starting at 0, we go to 1. Now it's important to note there, okay, it's always going to be 1 unless you've got something added to that. So generally it always goes through 1, because basically because anything to the power of 0 is always going to be 1. So unless you have the situation where it's 2 to the x plus 3, that situation there is going to be 1 plus 3 anyway. It's just anything to the power of 0 is always going to be 1. Okay, so there's our first point. If you have a look at the numbers as we increase, so 1, 2, 3, all the way up to positive infinity, all these numbers here are going to go to positive infinity as well. Just at a quicker rate. So everything on the right hand side is going steadily up towards infinity as we increase our x values. As we decrease our x values, we get smaller and smaller and smaller, and we're heading towards 0. Okay, we're never going to reach it, so it's actually our asymptote. So you get closer and closer to that line, but never touch it. So that's what 2 to the power of x is. And we always go through 1 unless we've been moved up or down. Just as a quick little note, just redraw our axes. So this is y equals 2 to the x. Now I asked the question before, what happens if we had y equals 2 to the x plus 3, I think I said. So we're going to have a situation where we go 2 to the x is, well, 2 to the power of 0 is 1 plus 3, so we actually go through the point at 4. But all these numbers here are basically shifted up 4 spots. So it's the same shape. Oh, it's horrible. Yeah, same shape. It's not very good drawn there. But we have an asymptote now that's been shifted up 4 spots. So what we can say is this is our vertical dilation. So if it's plus, we go up. If it's down, we go down. Well, if it's negative, we go down. So it's just shifting that asymptote up or down. So we can say y equals a to the x plus k. So k shifts it up or down. Now the other situation is, like our quadratics and cubics, etc., what makes it go left or right? So I've got my y equals 2 to the x. I just need to see what happens, or what makes it change, so that I have the same shape, it's just shifted across. So this value in here is going to be different, obviously. There's not really a way to investigate it. It's just equals y equals 2 to the 2 to the x minus h. So I might say it is minus 2, for example. So at 0, we get 2 to the minus 2, which is going to be 1 over 4. So this little spot in here is going to be a quarter instead of 1. So basically this minus 2 our h shifts it. Basically our h shifts it left or right. And we've had a look at all these before, so it's just a quick little refresher. So it might help to have a look at some more examples. So we've got part A, worked example 9, on the same set of axes, sketch the graphs of y equals 5 to the x and y equals minus 5 to the x. So if I get my calculator out, wants to work. There we go. And we go to graphs and tables. And we've got 5 to the power of x. And we've got minus 5 to the power of x. Sketch the two. Oops. When it wants to work, sorry, technical issues. Let's have a look. Okay, so there's, in the blue, we've got 5 to the power of x. In the red, 5 to the minus x. So again, if we go back, we can say that negative sign just reflects it in the x-axis. So negative at the front reflects in the x-axis. And if we just go back to the graph, and we're just going to change that minus up to the top there, and we should see a reflection in the y-axis if all goes to plan. Okay, so see the difference there? If we have to the minus x, it reflects it in the y-axis. So part B, give a possible equation for the graph shown. So we've got it going through 0, 1. It looks like it's one of these ones because we're going down, and so we've got a to the minus x. Just need to work out what that a value is. Now, if we go over here, we've got minus 1 and 5. Alright, so I can actually solve this. So 5 equals a to the minus 1, and obviously a equals 5. So my equation is going to be 5 to the minus x. Okay, so see what I've done there? Just indicate, okay, we're going down, so it means we've got a negative reflection in the y-axis, because most of the time it's going to be most of the time the positive is going to be like that. But we're going down, so it's negative x out the front of x, and then just need to work out what that a is. So that's it for B. Example 10, sketch the graphs of the following and state the range of each. Alright, going to do it by hand this time. So I've got 2 to the power of x, take 4. So 2 to the x we had a look at before. Looks like that. And we're going down 4, so it means our asymptote's being moved down 4. So I've got an asymptote along here. It's not very straight, but anyway. And now, when you draw it, this is 2 to the x. Just need to work out what these y values are. So this one here is going to be at 2 to the 0 is 1, take 4, so minus 3. And this one here, we let y equal 0. So we'll say 0 equals 2 to the x, take 4, plus 4. So 2 to the x equals 4. X has to be 2. Okay, that's it. Just need to label those points. Label our asymptote at y equals 4. And this is y equals 2 to the x, take 4. Now the next one, we'll make a new page. Okay, we've got 10 to the power of x plus 1. So set of axes. Now I've got 10 to the minus, so it means we're going down this way. And it's been moved to the left one spot. Okay, something like that. Again, just need to work out what our intercepts are. So at y equals 0, and we're just solving for x now. Hang on, no, that won't work because I'm solving for the wrong thing. We're trying to work out what our y value is. Sorry, just wondering why it wasn't working. Okay, so x equals 0. So at x equals 0, we have 10 to the so 10 to the minus 0 plus 1 is 1. So y is going to be 1 over 10 or 0.1. And that's it, just need to label that. Now it doesn't have any x-intercepts, so that's all we need to do. So question 11, sketch the graphs of each of the following, state the range for each. So I probably should have stated the range, actually. Yeah. So our range goes from about -4 to positive infinity, not including and not including. The range here is going to be from 0 to positive infinity, not including, or yeah, that's pretty much it. Okay, so I got 10 times 5 to the 2x take 1. Yeah, it might be worth just going, what's our y-intercept? That happens at 0, x equals 0. So 10 times 5 to the 2 times 0 is 0, minus 1. So that's going to be at 2. So we cross here at 2. Is there a x-intercept? Well, no, because we haven't been moved up or down. So we have no x-intercept. We don't have a reflection, so it's going to look something like this. That's basically it. Okay. Next one. Our range is going to be from 0 to positive infinity. this one, I'm going to rearrange it so we have y equals minus 3 times 2 to the minus x, and then plus 1. Might be easier for you. So we've got a set of axes. Alright, this one, it's been moved up one. This indicates we're going that way. And this means that we've got a reflection in the x-axis. So we've got a fair bit happening here. So I'm just going to first deal with the asymptote. So I've got an asymptote at positive 1. So that's indicated in the white. Now, 2 to the minus x means that it's going like that. And that minus 3, the minus means we reflect it in the x-axis. So everything gets reflected in the x-axis, meaning we now have the asymptote at minus 1. Okay, so not very well drawn there, so it should be approaching that one there. So again, our y-intercept, we could have done this first actually. Y-intercept, let x equal 0, so y equals minus 3 times 2 to the 0 plus 1. 3 times, that's 1, plus 1, so minus 2. So that spot there is a minus 2. And that is a y equals minus 1. And that's essentially it. So not very well drawn. My scale is a little bit out, but you get the idea. So it's just going through the steps and seeing what changes, what happens to what. So that's 11.4. That's graphs of exponential functions. Have a go at some of the questions and make sure you ask for help. Thanks.